there was a tool I could use to help me search for what I'm looking for. What? What's this? Find. Maybe I can use this to help me search for what I'm looking for. Let's give it a try, I guess. Guess it didn't work. Hey, what's that? Let's see what juicy ideas this thing has in store. Oh my goodness. This thing is so full. Great. Now, if only there was a tool to help me filter through all of these ideas to help me find something original. If only there was a tool. Hey, Grep. Ooh, this might be what I need. I mean, Find worked, so maybe Grep can help me filter through all of these. Let's give it a try. Grep, help me filter for original YouTube video ideas. Whoa, it looked like it worked. Let's see what it's found. Well, this was an entire waste of time. I guess if there's no original YouTube video ideas, then I'm just gonna have to make a video on how to find in the terminal. Let's do this. Hi there folks, my name is Ben and welcome back to the channel. As always, if you haven't already, consider hitting that subscribe button, and of course, if you like this video, give that thumbs up icon a little tickle. Let's jump straight into the topic of this video, which of course is how you actually search for in the terminal. How you can quickly, effectively, and easily locate the things that you're looking for using the power of your command line. Say, for example, you remember the name of a file, but you don't remember where that file is on your computer. Or you remember some of the contents of the file and want to try and locate it that way. Or perhaps you're already in a file and perhaps it's massive with loads and loads of lines and you want to find a particular string in that file. All of these situations and more can be solved by the two commands I'm going to show you in this video. These two very well-known commands absolutely need to be in every terminal user's arsenal, and in fact I would probably say that these commands are really useful for the average non-terminal user to know about as well. But the question does need to be asked, why aren't you using the terminal? The two commands in question are of course find and grep. I'm going to split this video into two separate sections, one for grep and one for find. And within each of these sections, I'm going to tell you about the basic usage of the command, apply it to some real life use cases, and then go into detail about some of the lesser known functionality. So feel free to use the timestamps and the chapters below to jump ahead to the bits that are interesting to you. Right. As always, let's jump over to the terminal. So in order to showcase these two commands, I have created a little playground folder that contains about 1,000 other folders underneath it called secret underscore and a number from 0 to 999. And if I quickly run the tree command, you can see the file tree sort of printed out graphically. You can see that each folder, secret underscore whatever, has 8 files within it. Info underscore A through to h.txt. And finally, if I just cat out any of these files from any of these folders, let's do secret 999, we'll do info a.txt, the files all contain the same text. This is a secret in the file. Great. However, there are some secret exceptions sprinkled into this folder structure in order to help me illuminate the power of the grep and find commands. We're going to use the two commands to search for these hidden exceptions. Right, one little important caveat to address before we jump in. Everything that you see in this video is running on a Mac, inside of the Mac terminal. The Mac BSD versions of grep and find are ever so slightly different and work ever so slightly differently than the GNU versions of grep and find. Now, you might go your entire time in the terminal using both grep and find and never come across these differences, and that is fine. And I'm not going to cover these small detailed differences in this video. I just wanted to make you aware of it. If you are interested in reading more about the differences between GNU grep and BSD grep and GNU find and BSD find, then there's this really great article on Ponder the Bits that I'll put a link to in the description down below that explains some of these differences and gives you sort of the examples that you can trigger it and see them for yourself. As I said, I won't go over the differences, however, I will show you how to spot the difference and install the GNU versions of the commands on your Mac, if you so choose. Really quickly, with the grep command, you can do grep tac capital V, and it will show you very quickly in the version information that it is BSD grep in this case that I'm using. Totally up to you which version you want to use, but if you want to install GNU grep on the Mac, you can do it using brew. First of all, make sure you have brew, the missing package manager for Mac OS installed. I'll put a link to brew down below, but once you have brew installed, you can do brew, install, and just grep, and that will install GNU grep for you. Then, once you've installed GNU grep, you can just use grep, but stick another G in front for GNU grep, and let's just do the tac capital V again, and you can see this time if I'm invoking GG grep or ggrep, GNU grep, it says this time I'm using the GNU grep version, whereas if I just did grep tac capital V previously on my machine, I'm using the BSD version. Similar with find, you can find the version of find that you're using by going to the man page, man space find, and if you can see right at the top, BSD currently for just find. And again, if I wanted to install the GNU version of find, I would do brew, install, and this time the package I'm going for is find utils. Once I've done the installation, I can refer to GNU find as gfind, as I did with grep, GNU grep, ggrep, so gfind. And just to prove that, I'll do man gfind, and you can see at the top, the BSD bit's missing, but if I use capital G to jump to the bottom of the file, you can see references to GNU just immediately, instantly there, so you know that you're using GNU find instead. If that has confused you, please do not worry, as 95% of the time you will never stumble across the different variations within the GNU and the BSD versions of these two commands. All right, let's start with grep. Before I dive in, if you want to hear a really interesting story about why grep is called grep, then I'm going to link you to a computer file video just here where Brian Kernighan himself explains the reasons why. It's really interesting. The most common usage of grep is taking some amount of text and string and finding a substring or a pattern within that string, within that text. It, for all intents and purposes, is taking a big load of input and filtering to find the bit that you're interested in. So as I showed you before, the contents of all of these files here is, this is a secret in the file. However, I changed exactly one of those files to include the word not. I think I said something like, this is not a secret, or something like that. We can use grep to quickly find the file and the line in question. Here's the basic usage of grep. Of course, we start with the command grep, and then we pass it the pattern that we're looking for. We can pass it straight up text, or we can pass it regex, of course. In our case, we're looking for the word not. After the pattern that we're searching for, we want to tell it where to look for, like in which folder structure. We can use the dot annotation. The dot in sort of Unix terminal world means this folder right here. However, if we run that as it is now, we'll get this error. Grep dot is a directory, which is right. Dot is a annotation for this folder here. What grep really wants in this place here is a file to search. It will take the file and its contents and search through that file. However, that's not what we want. We want to search every file in every folder in this folder. A big ask, but we can do that really easily with a flag. So if we do grep not, and then we use the tac r flag, and then again pass it the folder. The tac-r flag is for recursive mode. So we can pass it a folder and grep will go, oh, this is a folder. I'm going to search the folder and its folders inside the folders and the files inside the folders all the way down. If we run it, you can see it took maybe a tiny amount of time, a fraction of time to find it, but it has found it for us. And you can see on the left-hand side, it tells us the file location of the pattern in question. So you can see secret 584 info C was the one that I put the not word in. And of course, on the right, it's found the line that matches that pattern. And in this case, it's highlighted the word not because that was the pattern, the thing that we were looking for. Let me now go back and change that not to be capital N-O-T. Let's see what happens if I run it again. It's yielded no results, and it's actually come out with a 1 error code saying that essentially the command has failed. And that's because by default grep is case sensitive. However, of course, we can change that by adding the I flag for, if you like, insensitive, case insensitive. If we run the same command, you'll see this time it yields that same file that we had before. Now here's something relatively interesting. Grep returned the line, the whole line that sort of substring, that pattern was in. Maybe we don't want the whole line. Obviously that's our output. If we were putting this into a script or something, maybe that's not what we want. Because by default, grep will show the line that matches the given pattern and string. But we can toggle this functionality off incredibly easily by adding the tac O flag. And you can imagine O as like, show me only the matching pattern. If I hit tac with that now, if I hit O with that, it's got the case insensitive I flag, and it's got the O, so only the matching. You can see that the result is just the not word, none of the rest of the string like previously before. Of course, this is grep, and regex is actually part of the name of grep. The RE stands for regex. So we can provide it a regex pattern to do more sort of pattern searching or wildcard searching, if you like. If you don't know what regex is, then I'll link to some useful material in the description below. But just to highlight that regex works, I'm going to put in some regex here, and show you that it works exactly the same way. So this regex, in this case, again, I'm not going to go into the details, but dot means any character, star means any amount of times. Of course, I've put not as the actual string in question, and then I've done that whole any character, any amount of times. So what it's found, you can see highlighted again, the whole line as opposed to just the not word, because I said anything before the not, anything after the not. So that makes up that whole line. Next, you can use the tac C flag like this to say count occurrences. So how many times has that pattern been matched in the file or in the folders? So if I run that, you can see it prints out all of the files and folders and says there's 0 matches in this file and in this file. That's not super. Maybe I want to try and find the one match that we know about exists. And this brings me on to immediately the next example, which is taking the output of anything, in this case it's going to be grep, but taking the output of anything and grepping through it. We can use the pipes. In the Unix world, a pipe basically means it's a straight down bar character. It basically says, take the output of the command, the resulting output of the command on the left, so in this case grep not, and give it to this next command. So it's piping it through to the next command. And if you hadn't already guessed it, I'm going to use grep again, just to highlight the power of grep. I'm going to use grep, and I'm going to do :1, because I want to take all of this output, and instead of see all the zeros, I want to find the one that we know about exists, the one match, okay? And I'm going to hit that, and it will perform grep on the already grepped grep, if that makes sense. And important to note, the difference here is we didn't need to add, so this was our search term, if you like, this was our pattern. We didn't need to add a location because it's coming from a pipe, it's coming from standard in. So in that situation, we can omit the last bit of the location of where the file, the folder is, and we can just pipe it straight to grep. Next, maybe you actually want to find the exact opposite of what you're searching for. So in this case, I was searching for the occurrence of the word not. What if I wanted to find everything that didn't have a not? So invert the search, which is incredibly useful in some occasions. We can use the tac V flag to invert the results. So if I run grep not, you'll see all of the other files that just had the standard line, this is a secret in the file. The one occurrence where it said not is not in this list. Finally, with grep, one of my favorite lesser known functionalities is the ability to obviously search for something that we're searching for, a line in question, but also show me just a couple of lines before it, or just a couple of lines after it, or a combination of the two. And this is super easy with some flags. For this example, I created a file called example.txt that just has letters A to J, each on their own line. If we use the standard grep command, grep for D is our pattern in the particular file example, it will find, if I run it, D in that file, not particularly useful. However, if I wanted to see a couple of lines before it, I could add the tac capital B, so B for before, if you like, and I can give that a number. So if I just wanted to say one line before the line in question, you can see I'm still searching for D, it's highlighted it there, but I've said, also show me one line before it, and it's shown me C. Of course, I can change that to be 2, and it'll show me B, C, and D. Really useful. The other option to show a couple lines after, of course, is not capital B for before, it's capital A for after. It makes sense. And if I do capital A2 and run it, you can see, again, I'm searching for D, but it'll also show me the 2 lines after it, E and F. But what about if I wanted to see lines before and after, Ben? Do I have to do tac A and tac B? You could do, but there's a better way. Tac C for a combination, if you like, combination C for after and before. If I run that, you'll see there's D right slap dab in the middle, and it's got B, C, the 2 lines before and the 2 lines after it. So that was the all-powerful grep command. And grep really becomes incredibly useful when you combine it with regex patterns. Now over to the find command. Find, much like grep, is entirely a massive, incredibly powerful and versatile command. The most common use cases for the find command, instead, where we've got grep to sort of search for contents, find would be used to sort of find the actual files and folders themselves. Perhaps you have no idea or have forgotten about the contents, but you remember maybe something about the file's name, maybe an extension, maybe some substring of the file or folder's name. You can use find to locate that file or folder, and then, as an added bonus, you can even do stuff. You can execute commands on those files and folders that you might have found with one of Find's really powerful flags, which I'll show you in just a second. Find, as its default usage, is find and then a location. Again, I am just doing the dot annotation to sort of say this folder, and I've passed it nothing. So as a default, find will find everything in that folder and downwards. There is no limit on how far down into the depths it will go. So you can see as the output, I'm finding folder names and I'm finding files in the folders all the way down. Just to show you that find is traversing further down the tree than just sort of like the secret levels, I created a folder called deeper somewhere in this folder structure, but I've forgotten, but I will grep for the word deeper and we'll see it. So you can see the find command, again, has found everything in that folder structure and below. And you can see I created this deeper folder, which was just another sort of step deeper, just to highlight that find will continue to traverse down the tree. However, this depth that find goes to can be controlled, and that brings me nicely onto my first example. So to control these depths, find gives us a couple of options. If I just go into the manual page for find and search for the word depth, there are a variety of options. I can define the depth that it goes to search, and I can find more maybe usefully the minimum depth it will go to and then the maximum depth which will go to. And the maximum depth flag here is the one that I often use just to sort of limit how far down the tree it'll go. So again, if I use find and grep for that deeper folder, now I'll add our first tag, and it's this tac max depth and then a number to it, and I'm saying 0. So if I run that, the grep result here, who's looking for deeper, hasn't found anything. Let's just remove it and see what actually max depth 0 does. Well, it doesn't do anything because the max depth is 0. It's not even searched the folder like that it's in, okay? But if I change that to 1, we get a bunch of output. Note that we are only seeing the folders. It's just one level down. Remember, the files live in search, secret, and then in there. So if I add max depth 2, you can see now we get the folders and the files at the next level. And if we just go back to grepping for deeper, you can see when I've got max depth of 2 on, it will find the folder deeper. But if I change that to 3, another layer down, it finds both the deeper folder at level 2 and the text within that deeper folder at level 3. The max depth flag is really useful because, as I said, by default, find traverses all the way down the tree, which is time and resource consuming. So knowing the max depth flag and some of the other depth options will help reduce the scope of where you are finding. Okay, now that we know that, I have again sprinkled a little secret into this massive 1000 folder wide folder. The files, as we know, go from A to H. However, I do remember that actually there was an info_I file somewhere. I will do find and then the location that I'm interested in searching for, so in this folder, and then, how do I actually search for info I as a file name, for example? Well, as with the max depth flag, find provides you a bunch of useful flags to help you filter your search. The first one I want to show you is tac name. And if you hadn't already guessed it, this is saying, hey, find me a file or folder that has this name. And I'm going to put inside of it info_i.txt and run it. And immediately can see, hey, I found something. There's that pesky info I file in folder 711. Next, we can chain these tags. So I can do tac name with other tags. Let's learn some more of them. If I do tac type, that is saying, is it a file or a folder? So I could do F as the result here to say, yep, I'm looking for the name info I and it is a file. So it's, again, narrowing the scope. So that's type F. If I change that to D for directory for a folder, you'll see we won't get a result. We're looking for a directory called info_i.txt. That doesn't exist. Next, we can use iname instead of name for case insensitive searching. Again, it will be case sensitive by default, but if you use iname, I can change this info I to info capital I, and it will still find the same result, as opposed to if I just did it without the I name and just did name, you'll see there's no file with that name. If you're a big fan like me of regex expressions, then find has got you covered as well. Find actually allows you to use regex patterns in your searches. There are two important things to note here. Find provides you with this tac E flag, which when you add it, enables extended regular expressions as opposed to standard regular expressions. I'm not going to go into the details between extended and not extended, but again, I'll put links in the description below. Long story short, extended is often the way you want to go and contains sort of all of the regex like special characters. Whereas with the standard regex, you might have to escape a couple of characters. And the other thing to note is that find has a regex flag too, tac regex, and you provide it a pattern. And it will try and pattern match against the entire path of the file in question. So if it's in any subfolders, they'll be included. So a quick example of the regex flag. First of all, I have tac capital E to enable extended regular expressions. I'm searching dot this folder here and its subfolders. And then I've done tac regex with a pattern. And again, I've done that dot star, and dot is any character and star is any amount of times. I've done info underscore, and then I've done a regex grouping where I've said any character from A to H.txt. So if I run that, of course, it will find all of our files in question. Now let's go back to our previous example where I'm trying to find the file info_i, and let's use the regex power we've got here to help me with that. Right now, I'm searching for every file, I need the dot star here, every file from info_a to info_h. I is not included in that. If I run that, obviously that's not what we want exactly. We want to sort of flip it. We want to sort of say like, not this, invert the search, do the opposite. Like we had in grep with the tac v, we have something similar in find. So what we can do, we can add the tac not keyword, the flag, and what it'll do, it'll try and invert the next flag that we've got. So it's saying, hey, I'm looking for this and not that, the opposite of that. So if I run this now, we're not going to get the output we expect because look what we got. We got all the folders as well. They're included in our search. Don't forget find for find files and find folders as well. So what we can do, of course, we can use the type flag that we learned earlier and just specify F. We're just looking for files. And if I run that again, you can see our output is much smaller. There, of course, is the annoying info_i file and just some extra files that I've added for this demo. So hopefully you can see that find is really, really powerful, and combining these flags like tac name, tac type, tac regex, tac not helps you really create find the search that you want and narrow down the scope. Of course, there are a bunch more that I've not covered in this video, but if you go to the man page for find and start scrolling down, you'll see them. You can see tac ACL, tac atime, tac empty, blah, 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 blah. Exec is one we're going to come to in a second, but there are loads that will help you find exactly the thing you're looking for. However, there's one last really important and useful bit of find that I have to show you. That is the exec flag. And if I just open up the man page and search for tac exec, you can see here the information on it. Long story, very short, exec lets you perform actions on the search results of your find. Here's a really basic example to highlight it. If I have my previous find command to find the file that has the name info.i, I run that, great, nothing. It's given me one result. But now I can add the exec flag. And what this does is say basically, on all of the results of the find, on every result, perform this action. Let's just start with something really boring. Like, let's say we want to print the contents of the file of each file we found. So we know that the cat command can sort of give us that. It gives out the contents of the file. But how can we sort of combine it with this? Let me show you. After the exec flag, we give it the action we want it to perform. So I'm going to do cat, okay, to cat out the contents of the file. But what file am I referring to here? How can I refer to the file from sort of this side of the equation? Well, find gives you a sort of templating system. If I put in curly open brace and curly close brace, find will change that to be each variation of the find result. So for every find result, for every single result it finds, it will do cat and then that file, cat and then that file. So that might be it. However, if I run that now, we're not going to get the output we expect. It says find exec no terminating colon or plus. This might catch you out. Do not panic, there is a quick and easy fix. All we need to do is add 2 characters to the end of the line, but I want to explain why we're doing this. Our aim is to add a semicolon, okay? And a semicolon in the shell world sort of says like, this is the end of my command. And this basically lets us do command after command after command on the same line. Let me show you. If I do echo test, semicolon, echo hello, close that off. What this is going to do is interpret that command, echo test, and then echo hello. If I run that, you can see test was on one line, hello was on another because it did that command, semicolon, that command. However, as with everything, it is not that easy. If I add just a semicolon and run it, it's still confused. And that's because we need to escape this semicolon. The semicolon is a special character and we need to escape it. So to cut a long story very short, whenever you're doing the exec command over multiple results, you need to add / semicolon. That's it, that's that simple. If I run this command now, you can see we get this is a secret in the file. That is the cat command printing out the contents of info.i. Of course, with that now in mind, remember the exec performs the action on every result. So if I go back and change this I to a star to wildcard it, so I'm going to find every file with info underscore there, right? And perform cat on it, we'll see we get a bunch of output. And remember, all the files had the same content, so it performs the action on each file. Now, with that in mind, we can do whatever we want really in this sort of action space. If I just want to really boringly echo the name of each file for some reason between little hyphens, if I run that, you can see every file result that it's finding, it's printing between these 2 hyphens. Boring, but good to know. Of course, aside from catting and echo, we can do useful things with the exec command. That info.i file, what if I wanted to find it and delete it in one fell swoop? I, of course, could use the rm command for remove and use that little sort of like templating thing, the brackets to refer to the actual file being found. So my find query is find the file with the name info.i and then perform this action on it, delete it. So let's run that, which will quickly return. It didn't look like it did anything, but now let's try and find the file with the name info_i again, and we can see that there are no results now because we found it, and we deleted it. Right, let's take it one step further, and I'm really hoping I don't need these info files for the rest of the demo, otherwise this is really gonna hurt. But I'm gonna change info_i to be info star, and obviously when we run it, we find all of the files that are info something. Let's delete every single one of these files. So I'm gonna do tac exec rm, the template, the sort of the curly braces, my /:, and then I'm going to hit enter. And it's returned. Let's just ls. We can see that all of the folders are there, but let's do the tree command, which shows me the contents. And now if I just scroll up, you can see all of the folders are there, but none of the folders have any children at all. All of the info files have been successfully deleted. And that's the end of the brief introduction to the find command. Hopefully you've learned something new either about the grep command or the find command. Please don't forget that you can of course query the manual pages for both by typing man space and then grep, or man space and find, and reading through the manual page to learn a bit more. And hopefully this video has highlighted the power of the grep and find command to you, not only individually, but combined together, they create an ultra powerful toolkit in order for you to search for whatever it is that you are looking for. And that is the end of the video. Thank you so much for watching. Of course, if you'd like to learn more about anything that I've covered with the grep and the find command, there will be a load of links in the description down below. And as always, if you haven't already subscribed to the channel, consider doing so. And of course, hit that bell icon to be notified about when I release new videos. Thank you so much for watching. See you next time. Here. Yeah, that's pretty good. It's a pretty good frame. If only there was... Oh, this was an entire waste of time. Ooh, that was loud. Well, this was an entire waste of time. Oh, that's so loud. And... Let's do it again. Computer user. Nice, that was dope. Dive into the terminal to get this party started. What is that? What's that? It's dreadful. It's fine. I mean, it's garbage, but it's fine.